Morning. We're ready to start section 8.2 in your book, and this is on covalent bonding. And actually, how do those covalent bonds form? So, what is the difference between oxygen that we breathe and ozone in the atmosphere? Both are made of oxygen. Well, it's because they contain different numbers of atoms in that molecule, and the bonding is very different. So, octet rule in covalent bonding is the result of sharing electrons and not transferring them like in ionic bonding. So in covalent bonds, electron sharing usually occurs so that atoms attain the electron configuration of a noble gas. For instance, a single hydrogen atom has one electron, but when we make a hydrogen molecule, each shares the other's electron, which gives them 2 electrons, which makes them just like helium. So, the groups that generally form these kinds of bonds are in the nonmetals and metalloids, so groups 4A, 5A, and 6A, and 7A. They combine to acquire a total of 8 electrons, or an octet, by sharing electrons. So the octet rule applies. Hydrogen atoms in a hydrogen molecule are held together mainly by attraction of electrons between the positive 2 nuclei. The 2 atoms are held together by a single bond. Obviously, if there's single covalent bonds, there must be other types as well. So here we have a drawing of the Lewis structure for the 2 hydrogen atoms, each with their lone electron. Once they get close enough, they can share the electrons between the 2 nuclei and form a single bond. So an electron dot structure with the 2 dots represents the shared pair of electrons. However, we typically draw it as a dash to denote 2 electrons. So please, I think that'll be the first one I want to see in your notes. Please highlight that a dash is equal to 2 electrons. And so structural formulas are going to be very important. Dashes show the arrangement of covalently bonded atoms. So in fluorine, now we have a different situation. Not only are they sharing 1 electron between, 2 atoms are each sharing 1 electron, now they have these other things, those lone pairs. And how do we denote those on our formula? Well, we just leave them as dots. When we put in the dash for the single bond between the 2 fluorine atoms, we just leave the lone pair dots. And those are called unshared pairs, or I will probably almost always call it a lone pair. So we look at water molecules. We have 2 lone pairs on the oxygen and 2 single bonds between the hydrogens and the oxygen. So hydrochloric acid is prepared by dissolving gaseous hydrogen chloride in water. Hydrogen chloride is a diatomic molecule. Draw the electron dot structure for it. And so I've drawn here the 2 dot structures, one for hydrogen, one for chlorine. And when we bond them together, we shared 2 electrons between them, which I then rewrote with a dash. And this is the structure I prefer. I will accept the 2 dots, though. Atoms form triple and double covalent bonds by sharing either 2 or 3 pairs. So a double bond has 2 shared pairs and a triple bond has 3 shared pairs. So here we have carbon dioxide. This is something you breathe out every day. And it actually has 2 double bonds between the carbon and the oxygen, and each oxygen has 2 lone pairs. Nitrogen, which is the major component of our atmosphere, nitrogen has 3 unpaired electrons, and it ends up forming 3 bonds as 1 triple bond. So, when we do Oxygen atoms, they have 6 electrons, and so they do form a double bond because we would form one bond with that and one with that. It ends up having the lone pairs move so that they're out of the way. So here are the 3 halogens, oh, 2 halogens. There are 7 diatomic elements, and you need to know all 7. They do not list chlorine here, I don't know why, or iodine and nitrogen. So the octet rule refers to 8 of what? And that would be an atom. An atom is joined by covalent bonds to acquire 8 electrons in its valence shell. Coordinate covalent bonds is where we have a different type of bonding. If we look at carbon monoxide versus carbon dioxide, we see that it's a little different situation. We can form a double bond. We would have a lone pair for carbon, and we would have 2 lone pairs on oxygen. But if we count how many the carbon has, it only has 6, and it needs 8 electrons. So this is not enough electrons for carbon. Oxygen has 2, 4, 6, 8. It's satisfied. But since carbon is not, we're going to do something where we take one of these pairs and make another bond between carbon and oxygen. And that would give us a triple bond between carbon and oxygen. Each one would have a lone pair. This is called a coordinate covalent bond. And that's where one atom contributes 2 electrons to make a bond. In coordinate covalent bond, the shared electron pair comes from one of the bonding atoms. This is another thing I want to see highlighted in your notes. So this is number 2. We're going to stop here, and I will finish the rest of it in a second video. Have a great day. See you in just a bit.